So you're well past your first jump, and you know your gear, but now it's time to go deeper. So if you're in Category E of USPA training, or that's probably around level 7 in other programs, it's recommended that you start to learn how to pack your own parachute. In this video, we're going to move beyond the terminology that you learned in your first jump course, and you're going to learn things like what are crossports and why in the world would I ever want to cock my pilot chute? So I'm going to go jump behind the camera while Juan takes us through a walkthrough of the equipment and those new items that you need to know.
So now we're going to talk about how a canopy is constructed. Canopies are composed of basic 3 components: a top skin, which is the top of the canopy, a bottom skin, which is the bottom of the canopy and where the lines are attached, and the ribs. The ribs are actually the internal structure that gives the canopy its ram air shape. As you will see in the case of this parachute, they are black, they are vertical, which connect the top skin and the bottom skin to ensure that the geometry is correct. Additionally, there's something called the crossports. The crossports are holes on the ribs that allow cross flow of air between cells to maintain pressurization. The part of the parachute that we were just looking out to see the crossports is known as the nose. That's where the air goes into the canopy to ensure pressurizations. On the opposite side, it's the tail. The tail is where the top skin and the bottom skin come together. They're sewn together, ensuring that the air that enters through the nose remains inside of the canopy and is pressurized. As well, at the end of each corner of the tail, they are the control lines or brake lines, and these are the ones that allow us to control the direction of the parachute, or what we use for steering and landing. In the middle of the top skin, on the center cell, it's the attachment point for the bridle and the D-bag. This part of the parachute is reinforced to ensure that it is securely attached in place and is not going to separate or damage the skin during inflation. What you guys see here is the cross section of a parachute, same as if you were looking at it from the side while it's inflated. What you will notice here is that there are multiple sets of lines. All modern parachutes have 4 line groups that are identified alphabetically. The lines that come to the nose are called the A lines. The lines that go right behind would be the B. They are connected to the front risers. It is the same sets of lines that come from the risers that would then split in 2 into the B's and the A's. So one set of front risers will have lines that split to the front in A and B lines. Following the shape of the canopy, then we would have the rear riser lines that would come again to a point where the lines would split. Those splits are called the cascades, and that's where the line will divide in 2 and will go to the C lines and the D lines. This supports the back part of the parachute. And finally, on the end of the parachute or tail, as we saw earlier, the brake lines are connected. The brake lines run completely independent all the way to the back of to the control toggles. These lines are also cascaded because we only have one control line on each set of risers. And in this case, they will split in 4. So cascade into 4 independent lines that will go to the back of the parachute to give as much surface area as possible to control the flow or the flight of the parachute. If we move down the lines, we'll find the slider. The slider, as was explained earlier, is used to reduce the speed of the opening. It has grommets that keep each individual line group organized. As you can see here, the grommets are generally made out of stainless steel. Some older models are made out of brass. It is really important to inspect and ensure that there is no damage, no nicks or burrs that will damage the lines as the slider goes down the lines during the opening sequence. So it's an important part of the inspection of your parachute when you are repacking it. In the case of this slider is collapsible. A collapsible slider will allow you to reduce the shape of it from a rectangular shape to more like a bow tie shape. The only thing it does is that it reduces the friction or drag that it generates as the canopy is flying through the air. One important thing to keep in mind is that collapsible sliders would have to be unstowed or uncollapsed for the packing process. Otherwise, the opening shock will be catastrophic. It could damage the parachute. It could hurt you. So it's really important. All of them would have a sign that they cannot be left collapsed for packing. It is important to point out that in the case of the slider, student canopies do not have collapsible sliders. And that's just to ensure that there's one less thing to worry about during the packing process. Same as for the pilot chute. Modern pilot chute on non-student canopies are what we call collapsible pilot chutes. In this case, you will see the pilot chute is uncollapsed, meaning that when it's thrown into the air, it will catch air, inflate, and add a significant amount of drag. But after the canopy comes out of the bag, the pilot chute will collapse by means of a kill line that is inside, and now that pilot chute does not generate any drag. As with the slider, student canopies do not have collapsible pilot chutes to ensure that there is no risk of packing a parachute with a collapsed pilot chute, because in this case, as you see, this does not generate any drag. It would not open or effectively extract the canopy out of the container. So it is important that in the case of a collapsible pilot chute, that it is what people call cocked or uncollapsed before it gets packed. Now, by pulling it and holding the bridle, then it catches air again and it is ready to be packed. In recent history, we started connecting the parachute lines to the risers by what is called a soft loop. These loops are made out of a material very similar to the parachute lines. They are very strong, but the main benefit is that by being soft, they cannot or will not cause damage to the grommets during flight while the slider is hitting the connector. In the past, this process was being accomplished by using metal links. These metal links would connect through the riser and the lines, but then they would have to be protected with a type of bumper to ensure that when the slider was hitting during flight, it would not cause any dings or damage to the grommet that then later on would damage the lines. Another important thing to keep in mind is how over the years toggles have been secured to the risers. Initially, it was very common for the toggles to have Velcro on themselves and then on the riser, and then you would just secure the toggle in place by sticking the Velcro together. The main problem with that method was that Velcro wears out, but also that the Velcro, the hook side of the Velcro, could damage the lines. So all manufacturers have gone away from using Velcro on securing the toggles. There's many methods. In this case, there is a pocket to store the nose or the tip of the toggle once it's put in place. And this ensures that it's not going to easily come out. Even if the slider will bump it, it will protect it. And on the back side, this type of manufacturer uses a pin that would be inserted in the riser. And now you have a toggle that is secure, held secure in place by means of those two elements, the pocket and the pin.
And we hope that walkthrough helps you to understand how your equipment works and why. If you haven't already, consider subscribing to our channel and also take a look at the video that we did about MARDs, or Main Assisted Reserve Deployment Systems.